Chains are as indispensable today as they were thousands of years ago. Ancient historians refer to the use of metal chains for jewelry, shackles, and construction. Today, chains are used for those very same purposes and many more. Chains are a link with the past, one that we're unlikely to break. Chains are used to tie things down, hold things together, and pull things along, and their many sizes reflect the varied uses. To make a chain, a turning drum uncoils this wire rod and pulls it through a steel guide ring to a steel draw box. Grease inside the box lubricates the wire. On its way out of the box, the wire goes through a die, such as the one being demonstrated here. The die has a smaller diameter than the wire, and as the turning drum pulls it through, the wire narrows, hardens, and becomes stronger. Now, electrically driven tools move in from all sides. This is a forming machine. A tool called a jaw propels the wire forward, while another jaw pushes on the wire, bending it around a steel pin. It forms a C shape. Another forming tool closes the C, completing one link in the chain, and then another jaw makes the next link. This machine is making jack chain, which is usually used to hang lights. Another forming machine makes a chain that can haul a heavier load. A grip pulls the wire onto rollers that straighten it out. Steel cutters now make notches on both sides of the wire. These notches mark the place where the wire is to be sliced into link-sized pieces. A mechanized knife makes the final cut at the notches. Next, roller arms loop a cut piece of wire around a steel finger. The roller arms make it look easy, but they're actually exerting tons of pressure in order to shape this wire. After the rollers form the link, a pliers-like tool grabs it and turns it around. This positions the completed link so that it can connect with the next link as it's shaped. As each link is added, the chain drops into a pile below the machine. There are dozens of forming machines in most chain factories. Each machine makes 50 to 60 links per minute. That's approximately 76 meters of chain per machine per hour. To put that into perspective, one machine could make a chain as long as the CN Tower is high in just 7 hours. After the chain is formed, it'll need to be strengthened. So it's onto the welding machine. Hammers to the left and right push the link in. Then 2 copper blocks move in from the sides. They act as electrodes and zap both sides of the link with an electrical current. The current ripples through the gap in the link, while the hammers push it in. The link reaches a scorching 927 degrees Celsius. The wire melts, and the link fuses together. Now a pulley system drops the freshly welded chain into a heat treating coil. An electrical current runs through the copper coil, heating the chain inside until it's orange hot, 940 degrees Celsius. The pulleys lower the chain into a tub of water to cool. The extreme temperature change alters the molecular structure of the steel, making it much harder. But the experience leaves the chain a bit brittle. So it goes into a second heat coil that's not as hot as the first one, and then into another cool bath. This takes away the brittleness and gives the steel a bit of stretch. Now the ultimate strength test. This is the chain calibrator. Pulleys run the chain into a groove that's been cut into a block of steel. A clamp on the left holds it in place, while the hydraulically powered block of steel pulls the chain to the right. Will it break or will it hold? And can it handle the load? After all, you're only as strong as the weakest link. Roller chains carry a lot of power in our society. We're all familiar with them as the chains that move energy to the wheels of our bikes. But roller chains also transfer energy in industrial and agricultural machinery. They really keep things moving, and without them, a lot of important equipment would be powerless. To make a roller chain, a punch press pulls steel from a giant spool. Using 500 tons of force, it cuts shapes out of the steel. These shapes are the link plates that will join all the parts of the roller chain. The plates travel on a series of conveyors. An arm positions them as they head towards the next punch press that makes 2 holes in each link plate. A worker then pours them onto a tray and spreads them evenly across it. A vibratory mechanism shuffles them into a blazing furnace. This heat treatment toughens the steel. Then they cool down slowly in a tank of oil. After that, they go for a tumble in the washer to get rid of the oily residue. Meanwhile, another machine uncoils some steel to make bushings or sleeves for the chain pins. The blade slices the material to the correct length. Then mechanical arms fold the steel around a mandrel. Here's the action in slow motion. In real time, it all happens faster than you can blink an eye. The bushings fall into a bin. And now they're ready to be heat treated. They open the furnace and stand away from the blast. A rail car takes the bushings into the flames. This may look destructive, but the bushings will come out stronger. Now it's time to make the pin that will hold everything together. This machine shoves a steel rod into a jig and a saw cuts it to size, which varies depending on the chain it'll be used for. A mechanical arm then picks up the pin and transports it to rotating heads, which machine down the ends. The pins then travel across a grinding wheel, which reduces them to a specific diameter. Next, they go through a wash cycle. A special mix of lubricant and solvents rinses away the residue from the grinding. These are the pins before and after grinding. Now it's time to put the pieces together. This is a breakdown of what happens at a blurring pace on the assembly line. The link plates and bushings go into an assembly device. A ram presses them together. They remove them and place 2 more link plates in the device. They position rollers on top of them and slide the bushings and link plate assembly into place. They press fit it all together. And now they have links for the roller chain. The next step is to fit the roller links together. They clamp them into a fixture and slide in pins. A hydraulic ram presses the pins to the base of the assembly. Then they connect the pins with another link plate and press it in place. This is repeated as they lengthen the roller chain. They can also widen it to enable it to handle more horsepower. To do this, they stack single strands of roller chain. They use longer pins to hold all the layers together. Again, a fixture holds it in place while the ram does its work. This produces heavy-duty roller chain. The one shown can handle 400 horsepower. Finally, they lower the roller chain into a vat of hot grease to lubricate the joints. And that's the chain of events that leads to the roller chain.